2013 AP Calculus. Question 1, calculator problem. Workday, tons per hour of unprocessed gravel arrive at a plant based on this equation. Tons per hour. So again, first thing I'm thinking, integral with respect to time is going to give you tons. This is gravel delivered to a plant, measured in one shift from 0 to 8. At the beginning of the workday, there's 500 tons. All right, so it's 500 tons of gravel. So G of 0, all right, G of 0 equals 500. When you deliver it. So there's 500 tons sitting there. That's our initial condition. During the plant process of gravel at a constant rate of 100 tons per hour. Okay, so that means it's using 100 tons per hour. So there's something going on here. We're delivering gravel at a variable rate, G of T, and we're using gravel at a constant rate, 100 tons per hour. First question, find G prime of 5 using correct units. Okay, G prime of 5, well that's pretty easy, especially on a calculator test, and I think I did it right here. It's a little hard to see, but it says n derivative of the function at x5 is negative 24.5875. What I did here using the TI-84. And again, they had 2 answers on the test, so I went with those. And again, that's tons per hour squared. Just taking the derivative of tons per hour. And it says use the correct unit to discuss. The big thing here is you have to say at time 5 because the derivative changes. So I started right away with that. At time equals 5. What that means is the rate at which gravel is arriving is decreasing because it's negative at 24.587 tons per hour squared. This is worth 2 points, the value and the reason. So, and again, units are very important. So units are very important on this. So 2 easy points right there. B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. Okay, this is what the gravel that shows up. We just simply have to do the integral from 0 to 8 of G of T. And again, the units lead the way. Let's be clear about this. This is hours per units. This is tons per hour. And if you multiply these, you get tons. All right? That is very critical. And this is what's delivered. Not what's choose, but what's delivered. And again, it's I'm not going to show another picture of the calculator because I just simply put this in my calculator using that function of G of T. And the integral here is worth a point, and the answer here is worth a point. It doesn't say units, but you've got to make sure you have units. So again, 4 points in, out of 9 points, I'd say you're pretty well halfway. Is the amount of unprocessed gravel, letter C, at the plant increasing or decreasing at time equals 5? Show the work that leads to your answers. So is the amount of unprocessed gravel increasing or decreasing? Well, first of all, you have to realize that it's using 100 tons per hour. So if it's increasing, G of 5 has to be greater than 100, and if it's decreasing, it's going to be less than 100. So I'll have to just plug G of 5 in there. And when I do this in my calculator, I get 98.1408 tons per hour. That's how much is being delivered. Well, G of 5 is less than 100. So the amount of gravel on the plant grounds is decreasing. Thus, at time equals 5, unprocessed gravel is decreasing. All right, it's probably only worth a point. We'll see here. I'll finish up right here. Oh, no, it's worth 2 points. It's worth a point when you compare G of 5 to 100, and the reason's worth a point. So there's 6 points. All right, so you're 6 points in. So that means there's 3 points for letter D left. Let me move this out of the way. All right, letter D. What is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Okay, it wants a max. So guys, you gotta be thinking you have to have a derivative here, all right? And the thing is unprocessed gravel. We know the amount there. Let's call it, and they're using an A. So let's say that A of 0 is 500. That's what's there at the beginning of the shift. We're going to have to check the maxes and mins, and we're going to have to check A8, extreme value pair. We've got to check our endpoints. We're going to have to check endpoints. All right, and I might even put that note here myself, so I make sure I do it. All right, well, I'm going to need a formula to calculate A of t at any given time. A of t is going to be A of 0, the amount there initially, the integral from 0 to t, and the amount that's getting delivered is g of t. And what's the amount getting used per hour? Well, the amount getting used per hour is 100, right? 100 tons per hour. And that's probably what most students forget, dt. All right. So now I have to find A prime of t. So I find A prime of t. The derivative of this constant is 0, right? We take the derivative of that. And the derivative, fundamental theorem of calculus, keeps coming back and fighting us in the butt. We've got to get this, all right? It is simply, since it's just t, g of t minus 100. All right? And I'm going to set A prime of t equal to 0. Use TI-84, because I'm going to use that function. And I get a time of 4.9234. And again, if I'm going too fast, pause the video, make sure you can get these steps. So I have to do 3 things. I got to check A0, A of 4.9234, and A of 8. Now I could do the first derivative rule and check, but that's just, in this case, it just takes too much time. So maybe I make a quick table. 0 is 500, we know that. And we knew 8, we're going to have to plug in, and then 4.9234. And now I'm going to pause the video because I'm going to have to type these in my calculator. This is, I should have put this on before I pause. This is in tons. All right, so it's pretty easy to see the maximum amount of gravel processed. All right, again, a lot of work here. Let's see what I got. Considers A prime of t equals 0. This is why you want to note that. There it is. Boom. Has the answer. Boom. And the reason, which is part of this too. So actually, they're going to get credit for the answer, and this would be the reason in blue. So again, kind of a complicated problem. You got to catch and understand what's happening in the word problem, and often that's the big challenge. All right, keep practicing.